Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the introduction to chemistry. And we are going to be looking at the apparatus, that is the Bunsen burner. Previously, we looked at the parts of the Bunsen burner and also their functions. And we said that the Bunsen burner is the one that is commonly used in the laboratory, and the reason was because it forms two flames. So for today, we are going to look at now the flames, and we will start with one of the flames, which is the luminous flame. So we are going to look at the luminous flame and its regions, and we'll see how the regions come about and where they come from. And then we are also going to look at one question or some questions in regards to what we are going to discuss today. So let us begin. So a flame is a mass of burning gases, and when we use a Bunsen burner, it produces two types of flame, and this is dependent on the amount of air that is allowed into the chimney. So if a lot of air is allowed into the chimney, we form one flame. If no air is allowed, we form another type of flame. So we have the two types of flame. We have the non-luminous and the luminous flame. So we are going to look at the specifics of the luminous and non-luminous flame. And for today, we are going to focus on the luminous flame. So the luminous flame is usually produced when the air hole is closed. So when you close the air hole, there is no air that is entering into the chimney. So the flame that is usually produced is bright yellow. So this is the flame. It's bright yellow in color, and then it's large. You can see how large it is, and then it's wavy, and then it gives out a lot of light. We usually refer to it as luminous. And if you look at the definition of luminous, it means it's bright, it's illuminating, it's bright, and it usually has four zones. We have the thin pale blue zone, which is rarely seen. If you look at our flame, this flame, you may not notice the thin pale blue zone. And then we have the bright zone, which is covering most of the regions in the flame, as you can see. And then we also have some almost colorless region at the bottom, at the center of the flame, and then also we have some blue flame at the end. And you can see there's some air current. That's why the flame is very wavy. We are going to discuss how they are going to help with that specific flame or the color of the region at the bottom. So when we look at the different regions, the first region is the blue zone occurring at the bottom of the flame. So we said there's a blue zone at the bottom. So the blue flame usually occurs at the bottom because you can see some air current. There is air current at the bottom. So air mixes with the laboratory gas and the burning is complete. There's complete combustion. That's why it turns blue. And then as we have an almost colorless region at the center, the almost colorless region consists of the unburnt gases. The gases that are coming from the chimney that are unburnt are the ones that causes us to have the almost colorless region. And then as you go up into the flame, we have the bright zone, which covers most of the flame. The bright zone is usually very luminous and it's large. The reason why it's luminous or it's yellow, it's because it consists of unburnt pieces of carbon, solid carbon. This carbon comes from the gas, the laboratory gas. It is an hydrocarbon. So some of the carbon particles are not burnt. And the reason why they are not burnt is because there's not air that is getting into the chimney. There's no air getting into the chimney. So the unburnt carbon particles are the ones that are usually deposited on apparatus. They form the black soot. We see this a lot even when you are using the charcoal jiko. They usually form on the bottom of the sufurias and also the when you burn charcoal. So the air that is being supplied into the chimney is not enough. It's not enough to allow complete combustion. So what happens? There is an incomplete combustion. So the carbon particles are burnt and they glow. See that they are glow. So the glowing is the what causes that bright yellow zone, and it's quite large. It covers most of the regions in the in this flame. And the reason why it's so it's because there's not enough air that is getting into the chimney. And then we have another a thin pale blue zone. It's rarely seen, although it's there. The reason why it's pale blue is because the laboratory gas is mixing with the surrounding air. It's mixing with surrounding air, so it burns completely, and therefore it forms a blue zone. So you notice the blue color usually appears when there is complete combustion. So because it is mixing with a lot of air or plenty of air, it usually burns completely, and it's very difficult to see. Just like we have seen in the previous slide, it is very hard to see. So, what are some of the characteristics of this flame? So, first of all, the flame is usually large, quiet, and bright yellow. It's very large, and its color is not uniform, and it has four regions. It has four zones, as we have seen, and then it produces less heat because we said there's not the heat, the combustion is not occurring completely, and it usually gives a lot of light. A lot of light that is being given is because of the glowing carbon particles. They glow when they are heated. And then it produces soot. This is because of the deposits of the carbon particles, and it makes the apparatus dirty. So this flame has also some advantages. It's commonly used for lighting purposes, especially in candles. The candles that we use for lighting are usually having luminous flame, and the reason why they are commonly used is because of that brightness of color that they have. And then one disadvantage, actually, there's two disadvantages. It doesn't have a lot of heat, so it's not really used a lot for heating, even in the laboratory. But it is very bright, so it is easily noticed in the lab. And then it produces soot, which blackens the apparatus. This soot makes the apparatus dirty, so we do not use them. We do not use this flame for heating. So those are the two reasons why this flame is not for used for heating purposes. So let's look at one question. So the first question is: it's advisable to leave your flame in luminous state when not in use. Give a reason why. So the reason why we leave luminous flame in luminous flame is because it is visible. It's bright yellow. You notice later on when you talk about the non-luminous flame, you notice that it's not that visible to the eye, and so it can cause some accidents in the lab. But for the luminous flame, it's very visible. It's bright, it's large, so it's very visible. One of the flames produced by Bunsen burner is the luminous flame. Explain why this flame is very bright. So we said the reason why it is bright is because of the glowing carbon particles that are not burnt completely. So the reason why they are glowing is because they have not been burnt completely. That's where the bright color comes from. And then two disadvantages of the luminous flame: it does not have a lot of heat, and also it produces soot, which dirtifies the apparatus. So those are the two reasons why the luminous flame is not commonly used. So this brings us to the end. Next lesson, we are going to look at the non-luminous flame, and also we are going to look at the regions, and also why, if it's preferred and why it is preferred. See you in the next lesson.